Okay, hey everybody, I hope everyone's doing okay. Today I'm gonna go over deploying to the Kubernetes cluster with Octopus. This is something that we in at CUC texture. So I'm just gonna go over what we have found in our research and what we have been doing. So first, I'm gonna start with a brief introduction to Kubernetes. I know it's a big, Kubernetes is an enormous thing to describe, and I can spend, or anybody can spend more than an hour going over Kubernetes. So just as a brief introduction, Kubernetes is an open source software that helps you deploy, manage, and scale containers. The nice thing of Kubernetes is that it provides you with a framework to run distributed systems resiliently, and also that it takes care of scaling and failover for your applications. And one of the biggest things that I found out is that people sometimes don't know how to pronounce Kubernetes, so I added this small pronunciation help right here. And another brief introduction is Octopus. Octopus is a CI/CD tool. It's not as complete as Azure DevOps. I know that mainly everybody in SIMPAD has been working with Azure DevOps, but Octopus is just a part of that whole entire pipeline. You still need a source control tool like GitHub and Bitbucket, and you also need a build server like TeamCity and Jenkins. Other technologies I'm going to touch in the presentation is Docker, Azure Container Registry, and TeamCity. These technologies are part of the entire process that we use at Texture. And again, like Kubernetes and Octopus, going over each one of them it can be a whole lunch and learn. But right now I added a brief description of these technologies. Do you guys have any questions before I start? Okay, I'll keep going. So first I'm gonna describe what's a deployment target in Octopus. Octopus allows you to deploy software to different types of servers, Azure, the AWS cloud, and with also Kubernetes clusters. These machines and services are known as deployment targets. So how do we create a Kubernetes cluster deployment target? So first, as a requirement, in your Octopus server, you need to have installed a Kubernetes CLI tool. And for our example, I'm gonna use Kubernetes cluster in the Azure cloud. So another requirement is to have an account authentication for that Azure cloud, and also setting up your environments. So in our case, we have a dev, test, staging, and production environment. And in our scenario, also each environment represents one Kubernetes cluster. So to add a deployment target, after you have all your environments, and I can show you, can you guys see the browser?
Yeah. Yes.
So after you add your environments, you can go to infrastructure, deployment targets, and add deployment target. And in here, you can see all the different options that Octopus offers. And one of them is a Kubernetes cluster. So in here, you fill out the name. So I will recommend following the same convention, the same name as your cluster. So in our case, it will be dev texture services. And after the environments, you select the environment you created. You can create a target role or select an existing one. And part of that requirement is your authentication method. So in our case, it will be an Azure Service Principal. You select the account. You enter the cluster name. And the resource group. And this can be kept as default since Kubernetes default namespace is default. After doing this, you will have created your Kubernetes deployment target. Do you guys have any questions about this?
So, do you guys have the Kubernetes cluster on-prem, or is it hosted on Azure or something?
No, our cluster is hosted in Azure. So the nice thing about the Kubernetes clusters in the cloud, like in Azure or AWS, for example, is that all the Kubernetes cluster configuration is done by them. Because I think if you create a cluster in your server, you have to go through a bunch of configurations for it.
I see. Okay, thanks.
All right, anybody has another question? All right. So Lifecycles in Octopus. Lifecycles give you control over the way releases of software are promoted between environments. And usually the workflow, it has different phases. And in our case, each phase is the environment. So one will be dev, test, staging, and the production environment phase. These features also have a retention policies. So after you create a release for dev, you can configure the retention policy of the software that has been released. And as you can see, they occur in order, and you can add automatic deployments or make them manual. I think in Azure DevOps, this is also an option. So this is similar to that. So how you add a lifecycle in Octopus? I'm gonna move the browser back. So you go under library, lifecycles, and then add lifecycle. So here you will enter the name. And here's where you determine the retention policy. So I will recommend not doing the default, but setting what you need. You can do day or releases. And here's where you configure the phases. So this will be the pre-production phase. And you will add your environments. See that one I set it to automatically deploy. And the rest can be manual. And then I'll add a production phase. And the retention policy is inherited from what you set up here. After you create your lifecycle, you need to add an external feed to the Azure, to the Octopus configuration. So what is an external feed? In our case, we need a feed from Docker Container Registry. So as a part of our CI/CD process in our build server, that's where we build the image, tag it, and push it to the Docker Container Registry. In our case, since we work with Azure, we created an Azure Container Registry. And I will show you how to set up the external feed in Octopus now. So I'm gonna move the browser back. So under library, you will go to external feeds and then add a feed. Here you can select the feed type. So in our case, it's a Docker Container Registry feed. You can name it. And now all this information, you will need it. So in our case, we can go to Azure to see that information. Now I'm not gonna show you the password and stuff, but here you can see the login server URL. And then you can input the credentials from there as well. Then after you enter the password, you will click Save and Test to show you an example. So I don't show the password. I'll test it right here. And you can search for images that you have in your Docker container registry. As well, you can do this also with Docker Hub, but in our case, we don't use Docker Hub to store the images. So that's how we set up the feed for the Docker container registry. Do you guys have any questions? All right. So now we're gonna start getting ready to start setting up the project. So what is an Octopus project? An Octopus project lets you create and manage deployment processes and releases. You can define the deployment process, variables, and environments in which the software will be deployed and released. The nice thing is that variables can be scoped for environments. That way, you can have different values for each environment and you don't have to do this manually or hard-coded. And I'm gonna go over how to create a project in Octopus. So back in here, you'll go under projects. And the first thing you want to do is create a project group. So you will click add group and say, then after you create the project group, you can go ahead and add a project. So you'll set a name for your project. Let's do integration service. And here is where you select the lifecycle you created in the first steps. So in our case, it will be Kubernetes services. And then you just click save, and that's it for creating a project. Now I'm gonna go over deployment processes in Octopus. So the deployment process, it's how your software is gonna be deployed to the cluster. So it can follow different amount of steps. And the nice thing is that Octopus comes pre-packed with 300 and plus built-in steps. So in our case, one of those steps that we're gonna use is deploy Kubernetes containers. And I'm gonna go over setting up that step for the Kubernetes cluster. So once you have created your project, I'll use an existing one because I want to create a new one. You'll go to deployment processes and then add step. And as you can see, there's several different steps. So we select Kubernetes, and I'm gonna go over this one, deployment containers right now. But as you can see, there's different ones. So you can either do a script with a raw YAML file. You can upgrade home variables and all these other ones. So I'll select this one. And here you'll select your step name. So in our case, let's do deploy to KS. Here's where you select your target role that you created when you created the deployment target. And you'll give a name for the deployment. You can select the amount of replicas of pods are gonna be created with this deployment. I'm gonna leave it 1 as a default. And you can set up more stuff in here. Essentially what this is, it's a nice UI that Octopus has of a YAML file. So all these options, when you create a deployment YAML file for Kubernetes, it's the same thing. So instead of doing it all manually through a YAML file, you can do it through a UI. You can select the deployment strategy. In our case, I want to recreate deployments every time, so I will delete existing pods and create new ones every time. But you can select different ones depending on your scenario. You can add volumes, but we don't mess with volumes right now. And here's where you will add your containers. So here's where you, first, as you can see, the feed is the one that we the one that we created. So it's an Azure Container Registry feed. And in here, once your feed is set up correctly, you will see the different images available. You can select the ports and add more configuration for your pod container. And the one we use mostly right now, it's environment variables, because for each environment, we have different configuration. So one example will be the Azure log connection string. And you can keep adding more environment variables. As you can see, there's more configuration. When you see raw YAML file for deploying to a Kubernetes cluster, you can also apply these same values to the YAML file. But as you can see, this is a nice UI to do all that without having to create that YAML file. Then back in the deploy to the cluster template, there's a lot of different options you can do. Again, all these options can be set up through the YAML file. You can mainly leave most as the default ones. It depends your scenario, but in our case, we will leave the default ones. You will give your a namespace for your deployment. So let's do integration services. Here you will set up your service name. So in Kubernetes, you have pods, services, deployments. Up here in containers is a pod configuration. And here it will be the service configuration. You can select the service type. So if your service doesn't need the exposure to the out world and it only needs resources inside the cluster, you want to select cluster IP. If you need a load balancer so it can be exposed to the outside world, you will select load balancer, and here you can either specify an IP address or just leave it at blank and it will create one by default for you. But you will need to go and get the IP later. Now you need to add the service ports. So the most common ones are the UI ports. If you're deploying a UI, the port number, and you select the protocol. If you have an ingress controller, you can configure that in here as well. And like I said, you can add a lot of different configuration, as in the YAML file here through the UI. And all these can be left as default. But if you want this to run on specific environments, you can select it here as well. So let's say I want this process to be run only on the dev deployment. It will only be run through here. So like I said, there's a lot of configuration that you can add through that process, but this has to be done as needed. So not all the deployments are the same. Like one example in CUC, we're finding out that the RabbitMQ deployment needs to be totally different compared to the background services. So like I said, you will use this as needed, and sometimes you may want to use a raw YAML file because it allows you to add more configuration to the cluster. Now, setting up variables in Octopus. So I'm gonna discard these changes, go back to the project. Here on the project on the left, you can see variables. So these are the variables that I mentioned that you can set depending on the environment, or if they're all gonna be the same and they just change for deployment instead of compared to local development, you can set it here as well without defining a scope. So as you can see, all these variables are being used in our process. right now for this container deployment, we have all these environment variables that are needed. So instead of having it to do manually or hard coded, this gives us the freedom to change them throughout each environment.
Can you also specify the replicas?
For the, yeah, so I can do this as well. Let's say in in the pre-prod environments, we want only one replica. So if I do this, and then if I go back to variables, so let's say for our pre-prod environments, we only want one replica. You will leave it like that. But for our production environment, we want 3. So here you will select the production environment. So now every time all these processes are run, these 3 will have 1. But when this is deployed, it will have 3 replicas. And you can do that through for a lot of stuff in the processes. Every time you see this in here, is that you can add a variable. That's what it means.
Oh, okay, thanks. That's a nice feature.
Yeah, I don't know if this is something you can do in Azure levels, but I think you can probably.
Is this new in Octopus?
Not that I know of. Since I've been working with Octopus, this has always been there.
Got it, thanks.
I don't know if in older versions this was available. So now that we have our entire process configured and set up, it's time to connect this to the CI/CD pipeline. So the nice thing about Octopus is that it has an API. I think it's through profile. So here you can give yourself an API key, and you can use the Octopus API in Jenkins or TeamCity or other tools for CI/CD. So in our case, we use the API in TeamCity to create the deployments to Octopus. So as part of our build steps for the Kubernetes services, the last step is to create an Octopus release. So in TeamCity, there's also a already install Octopus deploy type, where you will input your Octopus server URL, the API key you created, and then the project you want to deploy to, the release number, and to what environment. So in our case, we always want to start with dev. And after you configure all this, you have finished your CI/CD pipeline from the build server to Octopus. And I can show you a small demonstration on how it works. So right here for this core integration service project. Well, before I show you, do you guys have any questions? No? Okay. So we want to create a new dev deployment for this project right here. So in TeamCity, I'm just going to start a new built for this project. You can see through the API, tell Octopus to create a new release for that. And it finishes deploying it to the cluster. Do you guys have any questions?
So maybe you're not aware, but do you know? I mean, how much in terms of costs? Because you had mentioned multiple tools like the container registry, the Octopus environment, even the pods. I think they also gonna generate some costs in the Azure. So I was wondering, do you know how much does it cost to have all this infrastructure in Azure? I mean, if we were to propose this as a solution for a client, just wondering if we have an idea of how much does it cost to have all these tools running and ready to be deployed.
So in Azure for a Kubernetes cluster, well, what it basically does, it creates virtual machines depending on the amount of nodes that you have. And you can also select the resources for that virtual machine. But it depends on your scenario. Like the standard, I think, is $100 a month for each node. So normally they recommend for a production environment that your cluster has 3 nodes. So 3 virtual machines, right? So this standard one is 108.57. So it's this times the amount of nodes that you have. So in this case, times 3.
I see. Okay, that's a good reference. Thanks.
Then also, if it also has to do if you add disk to the virtual machines to have bigger storage in your cluster. Because sometimes depending your scenario, you might wanna need that as well. But here in CUC, we host TeamCity and Octopus in one same server, in one same virtual machine. So I don't know how that compares to doing it through Azure DevOps. If you're gonna be saving more money doing that, or through Azure DevOps, or having one virtual machine with these tools, and you have, like you can see, a lot of projects that are run through that. Because I don't know how Azure DevOps charges you for each build that you do. So it depends on your client's scenario.
Okay.
And another thing is that you don't always want to use, like I said, that same deployment process, because in some cases, you will need a raw YAML to deploy to the cluster, or you will need to do some stuff after you deploy to the cluster, like upgrading values to an existing deployment or to an ingress controller. So it depends on the type of image and container you want. In our case, we chose this one because it's a simple background service that's running for the other applications. Is there any more questions?
Yeah, this is Johnny. I was wondering, you mentioned that there was some slight variations to how you did the deployment for RabbitMQ versus the background services. Could you potentially elaborate on that?
Yeah, sure. So for example, with RabbitMQ, there's different ports and protocols needed. So for example, in RabbitMQ, instead of having the regular ports, we needed to add these 3 ports for the service.
I see.
Normally for a UI, you'll just do port 80 and that's it.
Right. Okay, cool. So this didn't require a YAML file though? You could still use the configuration within the UI?
So right now it's doing this, but as we've been moving to deploy this to production, we're gonna change this to use a YAML file because we need to do more setup to the cluster for Rabbit.
I see.
But for the other services, not. So that's what I'm saying. If it's a more complex deployment, that yeah, it will be better to use a different type of process.
And so that YAML file, do you just include that in your source repo, or do you upload it to Octopus?
You will upload it to Octopus, and then you can read it. Use that YAML file to deploy to Kubernetes. So the deployment target stays the same. Everything stays the same. It's just a process that will change.
Right. Awesome. Cool. Thank you again.
So Ricardo, let's say you do the YAML way, this is Ashish, by the way. If you do it the YAML way, do you still have the ability to replace variables with Octopus?
Yeah, so let's say I'll do this one. So I think before you run through this step, you need to add another step to replace stuff in the YAML file. So that YAML file,
Okay.
we need to come in with that convention of the variables to replace it. Does that make sense?
Yeah, that makes sense. And so because the issue with having multiple clusters for the RabbitMQ, we're going to use the YAML version. Or no, we're using configuration, right?
We're gonna use Helm. So we're gonna do a Helm install in the beginning, and then we'll just upgrade the values for that Helm installation.
Okay, that makes sense. And then just maybe for everyone, can you explain Helm?
Yeah, sure. Helm, it's also an open source tool, and it allows you to install pre-made images to the Kubernetes cluster. So for example, this is the most common Helm chart. And here you have like RabbitMQ. So you have the regular RabbitMQ and then the highly available. There's also Nginx Ingress. So this is to install an Ingress controller in your cluster. Cert managers for getting SSL certificates for your user interface. The difference is that these projects are pre-configured with like the images they use. So this is not a Docker image, it's like a whole compilation of an image plus configuration to the cluster.
Got it. Thank you.
Yeah, is there any more questions? All right, so that's it. As I said, we've been exploring a lot with Kubernetes and the deployment process. We're still figuring out stuff and finding better ways to do deployments. Right now, me and Danielle are working on redeploying Rabbit with Helm. So I think when we get that done, we can probably go over using Helm to deploy to the Kubernetes cluster. And that's it.
Thanks, Richard.
Right. Thank you, guys.
Thank you, Richard. Thank you.
Thanks.